half angle, to get rid of a fraction, you just multiply by the denominator. You can divide by the half and flip everything over, or multiply by the denominator. So is everybody okay with this? So my solution from 0 to 4 pi are all of these, which makes sense. If I'm doubling, instead of having 4, I should have 8. 4 of each. Instead of having 2 of each, I should have 4 of each. Remember back to doing this, since you probably did it expecting to be here Friday and then haven't looked at it since? Okay. Next angle, I treat this like an x. I subtract. I say negative pi radical 2 over 2. That sounds familiar to me. My sign is negative in 3 and 4. That's where my y's are negative. So I could either set up Pythagorean's theorem here or say, oh yeah, I know this is a 45 because I can unrationalize it. I could set this up y over r. And when I find this piece, I say, oh, that's right. Same legs. They must be the same angle, 45. So I've got 4 pi over 4 and 8 pi over 4. So I can find my angles. I've got a 5 pi over 4 plus 2n pi and a 7 pi over 4 plus 2n pi. Excuse me. Once I get this far, now I deal with my multiplicity part. I divide everybody by 3. Yep, this comes out to be a little weird. 2/3. This 2 pi over 3. There's your 120, which makes a little bit of sense because there's 3 120s in 360. So it kind of makes sense that every 120 I'll have to flap another angle here. And all I do is set this up. Set this up again if you're dealing in 12ths, and we had 12ths before. Set it up again for 12ths. Our thirds, what are we in? 12ths, so we're going to have to convert this to 12ths, and we're going to have to convert that to 12ths. Just keep adding. And you should find 3 times the amount of angles. So if I expected 4 in 4 pi, I should expect 12 in 4 pi, 6 and 6. And leave them in radicals. And leave them in pies. Leave them in radius. The only thing you might have to do along the line is reduce your fraction, but normally if you reduce it first, you won't have a problem. God bless you. Good? And you guys that were absent, does it make sense? It takes a little bit to digest, but Gabby, does it make sense to you? Sorta. Okay, we're solving a regular trig equation. We're pretending that this is a plain old x, because this should say x. It shouldn't say anything in front of it. We're solving for a plain old x. Add 1, divide by 3. I've got an angle whose tangent is 1 over radical 3. When I take the square root, I get all plus or minuses, which gives me 2 positives, 2 negatives. Negative, negative, a positive, positive, negative, negative. So I have all 4 quadrants. All I have to do is get one of those. Get one angle and see where my reference angle is. So I know I'm at 30 degrees. Goes into 360 and 180 6 times. So this is 6 pi over 6. This is 12 pi over 6. And again, when you're opposite each other like this is half of my circle. So I can take this one, pi over 6, and add n pi. Then I can come and take this guy, because half my circle would hit this one. So this guy is 5 pi over 6 plus n pi. Those will hit all 4, because they're opposite poles from each other. Once I get here, where I normally am good at solving it, I say, okay, I got to take care of this double thing. If I expected 4 in 2 pi, and that means 8 in 4 pi, if I double it, I should get 16. 8 and 8. They always got to be even.
Aren't you supposed to add 2n pi?
Well, if you add 2n pi to each one of these, you could set all of them up and add 2n pi, but because they go across the pole, I only have to add n pi. So especially tangent alone will do this regardless of the plus or minus, because tangent has a period of 180. But because we're plus or minus and we're all four quadrants, if I hit quadrant 1 and add 180 to it, won't I come to this quadrant? Then I add 180 back here, then 180, then 180. It's a half twist. So the same thing with this guy. I will hit this one, back to this one, back to this one, back to this one. So instead of doing all four 2n pi, I just have to do 2 with n pi. If you did all four 2n pi, it's not wrong, but I would like you to try it with the n pi. So we convert these to the common denominator of 12ths again, very common denominator. And convert your 48 pi so you know where to stop. If not, in your head, say I gotta go 16, 8 and 8, stop at your 8th one. If you have trouble figuring out where do I stop, just figure out the double part. Good. You should be able to get this far, solving for the tangent, finding your reference angle. You should be able to get that far. Same thing goes on, and the rest of it is just kind of algebraic if you think about it. There's really nothing to do over here that involves angles once you set this up. The rest of it's algebraic. All right, let's take a look at the next one. Stop me if you have any questions. I've got one little section of my board it just does not like. Okay, this one has 4x. So we're not going to worry about the 4. Right away, we're going to just solve this as an x. We're going to, the ones there, we're going to divide this by 2. We're going to take the square root. When we take the square root, again, we get a plus or minus. That gives us all 4 quadrants. I'm missing an axis. We get all 4 quadrants. Just solve it for one quadrant. Find your reference angle. Up, that's my 45. All I have to do is name this one pi over 4 plus n pi. That'll get me this one. Then I'll name this one 3 pi over 4 plus n pi. That gets me that. Agree? Now I deal with my 4 times. I divide everything by 4. Gives me a lot of angles now. Work in terms of 16. Did I say, oh, I just said all solutions on this? All solutions. So actually all you have to do is just take everybody and divide it by 4 and say where n is any integer.
There is one.
Yes.
Would it be 2n pi?
Well, no, because again, I'm only going from here to this one. If you did 2n pi, did you do all 4? Who asked me that? Gabby, did you do all 4 plus 2n pi?
I thought it was cosine of the x.
It is cosine because it has a period of 2 pi. However, when you get to here, it's kind of, those rules don't apply anymore because you can go from here to here, from here to here. The positives and negatives don't apply once you get to this point. Once you get to this point, it doesn't matter which angle is positive or negative. You're just still going, every quadrant is going to have an angle. So you can still just go from here to n pi. Tangent automatically has a period of pi. So if it said the tangent of this, I would automatically do this for my tangent. And cosine, you're right. Cosine is either going to be here and here, oh, well, nope, here and here, or here and here. And I have to do 2n pi. But all bets are off when you do plus or minus. Because once you do plus or minus, you found your trig part. This is your trig part. After your trig part is done, you get this as an answer. Now the algebra part kicks back in. Okay, solve for x. Right. This is your trig part right up to here. And it says, I'll take all angles because you got every quadrant. Every quadrant's going to have this angle. It's either going to be a plus or it's going to be a minus.
I think it's just, like how do you know which one is the depending on all things?
Well, all 4 of you have to pick, start with your first one. You have to go this way. Pick your first one and go 180. Then just keep on going. Did I use this guy yet? Nope. Pick this one and go 180. And you'll cover all of them. It's always going to be the first 2 that you hit. N is any integer, we can have negative integers. But I would like you to stay on the positive note because we're usually going from 0 to 2 pi, from 0 to 4 pi, and keep it the positive way. Yes?
Could you put 4 and pi over 16 plus 4 and pi over 16. Because I like making the denominator the same.
Right. Well, yeah, and you would if you were going to do that, but for this one, I just said all solutions, so you didn't have to do that.
Would that be wrong?
So if you converted this to 16, add 4 pi, nope, that'd be fine.
Would have to put the n in it?
Yeah. Are you giving me all solutions, or are you just writing this out? You're saying it like this? That's fine. That's fine. Yeah. I thought you were doing that to find all your angles.
Oh, well, yeah, but...
Yeah. But it just wanted off. If you gave it to me that way, that's fine. It's just we don't have to set it up that way because I'm not asking you to give me any other angles. But that's fine. Okay, the next guy, square root again. What's troubling you guys is this plus or minus. This plus or minus still means I just have to pick this quadrant and go 180. Then I'd say pick this guy and go 180. Once I determine where I am, plus or minus is, I just need to rotate around and keep giving me angles because it's either going to be a plus or a minus, and I don't care which it is. This does not say to me, these are all positives, these are all negatives. These say, these are all my angles, all my answers. And again, deal with the 3 at the end. Just divide everybody by 3, and you just needed an all solution. And don't forget to say where n is any integer. Like I forgot to. Not bad, right? I mean, it looks harder than it is. What you guys didn't do last year were multiple angles and half angles. Yeah. In trig, we had these horrendous formulas, and you probably saw them on your formula sheets, especially the half angles. The half angles had these big radicals, these big square root signs. You had to do like the square root of the cosine of something over something else, and the other ones you had to do 2 times the cosine sign, and you had to do all these crazy things. In precalc, usually the kids are like, oh, this is so much easier than trig, but you didn't do them in trig, so they look a little different now because you never saw the other way. But these are the way we solve them. Kind of makes sense, as opposed to when you had to do those formulas. But you didn't do the formulas, so.
Yeah, we didn't get to 1 with number 6 though.
Right, but it's the same process. Same process. So you're going to solve this. All I did was take out the 1/2, just treat it like x, right? Where is my cosine positive? Cosine is x. Find my reference angle. So this is pi over 4. This is 7 pi over 4. So I'm going to start like this. Same thing that we normally do. How do I solve for x? If it's 1/2, I could divide by 1/2, right? Like we divided by 3, we divided by 4. And I could do keep, change, flip. This is a little messier. Can I just multiply everybody by 2, by the denominator? This is algebraic. Your trig part is done. When you wrote those out, your trig part is done. The rest says solve for x. So how do I get x by itself? It's a fraction, multiply by the denominator every term. So if I'm looking for all solutions, all I have to do is this. Multiply this by 2. However, don't leave this 2 pi over 4. Reduce it. Because doesn't that make sense? If I was going to do every 45, wouldn't I now do every 90? Because I want half the amount of angles. So doesn't that come out to be 90? If you think about it, right? So just make sure you reduce it and multiply the last part. Same thing here. Just multiply this and reduce it. 2 goes into this 4 times 14 over 4 and just reduce it. Oh, from 0 to 4 pi.
Oh.
Sorry, from 0 to 4 pi. From 0 to 4 pi, because you half angled this, if you got 2 from 0 to 2 pi, and you took half the amount of angles, how many angles would you get from 0 to 4 pi? From 2 pi, let's just do 2 pi. If you had 2 from 0 to 2 pi, and you halved it, so from 0 to 2, you'll only get 1. So from 0 to 4, how many should you get? 2, because you halved it. So actually using the fraction one is, I think it's easier because you're multiplying instead of dividing. You could divide. You could divide everything by 1/2. 1/2, just remember it says keep, change, flip. Which is worse. I just prefer multiplying it by 2.
But then we have to do where n is
Where n is,
all or any integer.
yeah, for this, yeah. Where n is any integer.
Oh, it says 0.
Well, yeah, this one you had to find all solutions in the interval of here, but if I left it here, I would have to qualify this. I left all my qualifiers out for some reason. But yes, you only had to find these two. And if you converted this to halves, this is only 8 pi over 2. So once you reach 7 pi, you can't add anything else to that, right? You're out of the domain. The half angles look worse, but they're actually, I think they're easier. And the last one, again, solve it as if it was an x. You've got a 60-degree angle, goes into 180 3 times. So we have a 4 pi over 3, and we have a 5 pi over 3, plus 2n pi, where n is any integer. From 0 to 4, just divide everybody by 2. And then, I don't know, something got messed up in here.
Yeah.
Yeah, I don't know what
I
happened
know
in
where
here.
6.
Something got written over here.
Oh.
I think this is from the one above it, isn't it?
Well,
Oh, no.
it is reduced.
I reduced this. I don't know what happened here. Oh, maybe I did write it. So make sure you reduce. And here's another thing. If you reduce it once here, you never get stuck reducing it here. If you don't reduce it first, once you do them all out, you're going to have to reduce at least every other one. So do it here, up here, and then you don't have to reduce it again. Yeah, it looks like there's 2 different denominators, and there are, but that's okay. There's 2 different sets of angles. You still should come out with your 8 angles. And you're going to have to reduce them all at the end. So, reduce them.
The top row over 6.
You could, but you would have to reduce them after you get there.
You would?
Yes, because 4 pi over 6 has to be reduced to 2 pi over 3. So that's why if you reduce this one here and add those with a different denominator, with just the 3's, you'll be fine. Same thing, you know when you do your trig functions and you find a triangle and you write your xy, and your r? If you reduce it there, you don't have to reduce any of your trig functions because it's all reduced by then. Make sense? It looks a little odd that we have 2 different denominators, but it's just the way it reduced. Questions at all? No questions. Okay. This is technically the end of trig.